Have you ever stared up at the night sky, a vast canopy of glittering stars, and felt a sense of profound wonder? Have you ever asked yourself, the biggest question of all, where did all of this come from? For generations we've told a story. It's a story of a single, brilliant moment. A moment when everything, all of space, all of time, all matter and energy, burst forth from an infinitesimally small point. We call it the Big Bang. It's the grand opening act of our cosmic drama. But what if that wasn't the true beginning? What if it was just the start of one chapter in a much, much larger book? This isn't just a philosophical daydream. It's a question that hums at the very edge of modern physics. The Big Bang theory explains so much, from the expansion of galaxies to the faint, ancient light that still bathes the cosmos. Yet it leaves us standing at the edge of a cliff. The theory describes what happened a fraction of a second after the beginning, but it falls silent on the moment of creation itself. It can't tell us what caused the bang, or what, if anything, came before it. Imagine trying to understand a great river by starting your observation a few feet from its source. You could learn its flow, its currents, and how it carves the land, but you'd have no idea about the hidden spring or the mountain snowmelt that gave it birth. Asking what came before the Big Bang is not a sign of doubt in our science. It is the very engine of it. It pushes us to think outside the box, to challenge our most fundamental assumptions about reality, to consider ideas that sound like science fiction, yet are grounded in the rigorous mathematics of theoretical physics. One of the most mind-bending of these ideas turns our perspective inside out. Our sprawling universe might itself be contained within something else. Something dark, mysterious, and incredibly powerful. Something we call a black hole. Let's rewind the cosmic clock. About 13.8 billion years ago, our universe was unimaginably hot and dense, a searing speck of pure energy. And then, in an instant, it began to expand. Not like an explosion into empty space, but as the expansion of space itself. In minutes, protons and neutrons formed the first nuclei. Hundreds of thousands of years later, atoms formed, and a flash of light, the cosmic microwave background, was released. It's a scientific triumph supported by mountains of evidence. But every great theory has its limits. The Big Bang nails the what and how, but hits a wall at the why and the before. At the moment of the Big Bang, our current laws, even Einstein's general relativity, break down, predicting a singularity of infinite density. Infinity is a sign our math has reached its limit. Physicists explore string theory and quantum gravity for a deeper description. One possibility, the Big Bang singularity might be connected to the kind found in a black hole. Let's imagine a massive star. Fusion pushes outward, gravity pulls inward. When fuel runs out, gravity wins. The core collapses catastrophically. The gravitational pull becomes inescapable. Not even light can get away. The point of no return is called the event horizon, a one-way door. Cross that threshold and all paths lead to the center, a singularity where space and time, as we know them, cease to make sense. The math of black hole singularities echoes the math of the Big Bang. Are they two sides of the same coin? Could collapse in one universe trigger an explosive expansion, a Big Bang, in another? The black hole cosmology model proposes a mechanism. Inside, quantum effects could cause a rebound rather than an infinite crush. When a massive star collapses, an event horizon forms. From outside, it's a black hole. Inside, the rebound becomes a cataclysmic expansion. A new universe is born. In this picture, our universe is what's on the other side of that one-way door. Think of Russian nesting dolls. The black hole universe theory paints a similar picture of the cosmos. Our universe may be one doll inside a larger parent universe, and our black holes could seed new baby universes. In this model, the Big Bang wasn't from nothing, it was inheritance. Collapsed matter became the raw material for our own beginning. This could help explain why the universe looks so uniform on the largest scales, an alternative to inflation's rapid early expansion. It changes our perspective on time and creation, suggesting a potentially infinite cycle of birth, life, rebirth. One universe's collapse leads to another's creation. Our universe is one link in this magnificent chain. If we're inside a black hole, why don't we feel crushed? Near an event horizon, space and time swap roles. From inside, the singularity isn't a place we're falling toward. It's a moment in time, the Big Bang in our past. The direction out of the black hole doesn't exist for us, only the future, the ongoing expansion of space-time. It's a mind-bending flip of perception. If our universe was born inside a black hole, could we find proof? Look to the oldest light. The the cosmic microwave background. The CMB is nearly uniform but with tiny variations, seeds for galaxies and clusters and the great voids between. A parent star's spin could imprint a preferred direction, alignments or asymmetries in the CMB, like droplets spiraling off a spinning basketball. Planck found curious large-scale alignments and asymmetries. They might be flukes, or hints consistent with black hole universe models. The black hole information paradox led to the holographic principle: information isn't lost. It's encoded on the horizon's two-dimensional surface, like a hologram. Could our 3D reality be a projection of information stored on a distant boundary, the edge of the cosmos? If our universe is inside a black hole, the holographic principle provides a natural framework. Our boundary is the event horizon, our information encoded on its surface. This elegant idea solves the information paradox and offers a new way to view space-time. It's crucial to remember, this is speculative, a compelling, mathematically plausible story connecting deep puzzles in physics. The standard Big Bang model, backed by decades of observations, remains our best account from the first second onward. But science pushes beyond the known, to ask what if and to explore beyond the edges of the map. From Earth at the center to Copernicus and Galileo to Hubble's galaxies, each shift expanded our place in the cosmos. Black hole cosmology stands in this tradition. Bold ideas that stretch our minds and test the limits of intuition. They may be right, or stepping stones to an even deeper truth we can't yet imagine. The important thing is to keep asking. We must build bigger telescopes, devise clever experiments, and encourage bold thinkers to dream. Science isn't a dusty book of settled facts. It's a living, breathing, dynamic endeavor, a detective story where the mystery is the universe itself. We gather clues, form hypotheses, test them, and slowly reveal a more complete picture. Perhaps our Big Bang wasn't the ultimate beginning, but one event in a vast multiverse of black hole universes, an exciting clue we're pursuing. Are we living inside a black hole? We don't know, but asking changes our relationship with the universe. The nature of space, the flow of time, the origin of everything, still open for discovery. Let awe wash over you. Stay curious. The universe is waiting for us to ask the next big question. The adventure has just begun.